Lesson 4, Mutually Exclusive Events. Let's just do a quick review. In mathematics, the event A or B, written as A union B, is said to occur if the event A occurs, or if the event B occurs, or if both events occur. The event A and B, written as A intersect B, occurs if both event A and event B occur simultaneously. Now the question is, when do we add the probabilities? Let's take a look at situation 1. If each of the 13 outcomes in the sample space is equally likely, find the following probabilities by counting the outcomes. So we're going to take a look at the Venn diagram just to the right. The probability of A, we have 4 dots in the set A, 13 outcomes altogether, so the probability of A would be 4 out of 13. The probability of B, we have 3 dots in set B, so that would be 3 out of 13. The probability of A union B, we would just add the 4 dots from A, the 3 dots from B, and we would have 7 out of 13. And the probability of A intersect B, there are no dots that are shared between A and B, so that would be 0 out of 13, or just 0. What is the relationship between the probability of A union B, the probability of A, and the probability of B? Well, the probability of A union B is equal to the probability of A plus the probability of B. Events A and B in this situation are called mutually exclusive because there are no outcomes in common. Let's take a look at situation 2. Again, if each of the 13 outcomes in the sample space is equally likely, find the following probabilities by counting the outcomes. So our Venn diagram has just changed slightly. The probability of A would be all the dots in set A, which is 4, so 4 out of 13. Probability B, we count 5 dots, so that would be 5 out of 13. The probability of A union B, we'll count the 1, 2, 3, 4, 5, 6, 7, 8, so it's 8 out of 13. And the probability of A intersect B is that 1 dot that overlaps between A and B, so that would be 1 out of 13. Now, what is the relationship between A union B, the probability of A, the probability of B, and the probability of A intersect B? The probability of A union B would be the probability of A plus the probability of B. But if you notice that 1 that's in the middle, we ended up counting it twice, so we have to take it away. We have to take one of those away. So we would subtract the probability of A intersect B. Events A and B are not mutually exclusive here because A and B share a common element. Let's summarize this as the addition law. A is just the general case, where if we have an overlap, or they are not mutually exclusive, probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. But we have a special subcase here. If A and B are mutually exclusive, then the probability of A union B is equal to just the probability of A plus the probability of B. Example 1. A card is randomly drawn from a deck of 52 playing cards. To find the following events. S is going to be that the card is a spade, R is the card is red, and F is the card is going to be a face card. Let's identify these events, S, R, and F, on the sample space. So the spades would be the column on the right. I have outlined them in blue. The red cards would be all your diamonds and hearts. I have outlined them in red, and the face cards are the queens, kings, and jacks, and I have outlined them in green. So which of these three events are mutually exclusive? If you notice, there's no overlap between the red cards and the spades, so it would be S and R. Now determine the following probabilities directly by counting the outcomes. The probability of spade would be 13 out of 52. The probability of red would be 26 out of 52. The probability of spade intersect red is 0 out of 52. There's no overlap here. And the probability of S union red would be, then added together, the 39 out of 52. Now, the probability of spades again is 13 out of 52. The probability of a face card is 12 out of 52. The probability of a spade and a face card at the same time is 3 out of 52. And the probability of S union F would be 22 out of 52. So using the addition law, you would have that the probability union of S union R is probability of S plus the probability of R. Since they are mutually exclusive, that's all we need to do. It would be the 13 out of 52 plus the 26 out of 52 to get 39 out of 52. For the probability of S union face card, that would be the probability of S plus the probability of F minus the probability of S intersect F. So this would be 13 over 52 plus 12 over 52 minus 3 over 52, which would give us 22 over 52. Example 2. There are 30 students in a class. 16 students use the text messaging, and 10 students use email. Of these students, 6 students do both. What is the probability that a randomly selected student in the class texts or uses email? Let T represent the students that text and E represent the students that email. So we've got two ways of doing this question. So the first way, we're going to use the formula. So the probability of T union E is equal to the probability of T plus the probability of E minus the probability of T intersect E. We would have 16 over 30 plus 10 over 30 minus 6 over 30 to give us 20 over 30. And this can be reduced to 2/3. The second way of doing this problem would be to draw a Venn diagram. So in a Venn diagram, we have our subset T and our subset E, and the overlap would be 6, because we have 6 students that do both. We have 16 students that text. So 16 minus 6 would be 10 that text only. And we have 10 students that email, so we would have 10 minus 6, or 4 students that email only. So now the probability of T union E, we would just add those three numbers together. So we've got the 10 plus the 6 plus the 4, which would give us 20 over our sample space of 30, which would also be equal to 2/3. Example 3. Wilma, the web whiz, submits bids on 2 web design projects. She thinks she has a 70% chance of getting the first project, but just a 50% chance of getting the second. She puts only a 25% chance on getting neither of the 2 projects. Find the probability that she gets at least one of the 2 projects. Let's look at this as the complement. So the probability of the first union the second would be 100% minus the probability of getting neither, which is 25. So that would be 100 minus 25, or 75%. For the probability of getting both projects, we're going to complete the Venn diagram. So we know that 25% is for neither, and altogether for the first and or the second would be 75%. The first is 70%, the second is 50%, and we could work these out so that we now know that the overlap would be 45. The first only, since it has to add up to 70, would be 25, and the second only, since it has to add up to 50, would be 5. So we can see now that the probability of F union S would be 45%. The last two parts are really easy now because we just have to read them off the Venn diagram. So for C, only the first project, that would be 25%. And for D, only one of the two projects would be 25 plus 5, which would be 30%. Our last example, example 4. Use the given information and the probability formula to determine whether the event A and B are mutually exclusive. So we're given that the probability of A is 1/4, the probability of B is 1/3, and the probability of A union B is equal to 7/12. If they are mutually exclusive, then the probability of A union B would be equal to the probability of A plus the probability of B. So we test this by first figuring out what the left side would be, and then what the right side would be. So the left side is the probability of A union B, and that's been given to us as 7/12. For the right side, we're going to add probability A plus probability B. That would be 1/4 plus 1/3. But remember, when we add fractions, we need common denominator, and in this case it would be 12. So the 1/4 would become 3/12. The 1/3 would be 4/12. When we add those together, we get 7/12. Indeed, we get that the left side is equal to the right side. So A and B are mutually exclusive.